I want to show you how powers of I work. So right now we're going to talk about powers of I. So remember that I is the square root of -1 by definition. So I squared would equal -1. It's sort of like this. You have I is the square root of -1. Okay, and if you square both sides of the equation, okay, the square root and the square sort of cancel each other out, so you'd have I squared is -1. So that's where that comes from. Okay, now let's find out what I to the third power is. What's I to the third power? Well, I to the third power is going to be what you get when you multiply both sides of this equation by I. So I to the third is -I. Now the reason again is, okay, you know that I squared is -1. So if you multiply both sides by I, then you have I times I squared is I to the third, and -1 times I is -I. Okay, what about I to the fourth? Well, let's take a look at that. So I to the fourth is, you can write it like I squared times I squared, right? That's what I to the fourth is. And you know that I squared is -1. So I to the fourth is really -1 times -1, which is 1. So I to the fourth power is 1. What about I to the fifth power? Let's keep going. So I to the fifth power, that is I to the fourth times I. And we know that I to the fourth is 1, so I to the fifth is just I. See, I to the fourth is 1, and 1 times I is I. So I to the fifth power is I. Let's continue. What about I to the sixth power? So I to the sixth power can be written, so I to the sixth power is I squared times I squared times I squared, right? Which is -1 times -1 times -1, which is -1. So you want to start seeing a pattern here. I to the 6 is -1. I to the 6 turned out to be the same as I squared. Let's do a couple more and establish a pattern. I to the 7th. Okay, what do you think I to the 7th is going to be? Well, if you said -I, you were right. -I. I to the 7th, remember, I to the 7th is I to the 6th power times I. And you know that I to the 6th, we just found that, that's -1. So it'd be -1 times I, which is -I. And then when we go to I to the 8th power, I to the 8th power is I to the 4th times I to the 4th. So I to the 8th power is I to the 4th times I to the 4th, which is 1 times 1, which is 1. So we're at 1. So you're going to notice that it repeats every 4. Okay? I to the 4th is 1. I to the 8th is also 1. That means I to the 12th will also equal 1. Now let's go ahead and do one that's a little bit higher of an exponent. So let's say we want to do I to the 41st power. Well, we know that it cycles I, -1, -I, 1. I, -1, -I, 1. So every fourth one, we're going to get the same number. So what we're going to do here is I'm going to take 41, the exponent, and I'm going to divide it by 4 using long division. And I want to see what the remainder is. So 4 into 4 goes 1 time. 1 times 4 is 4. Okay. When I subtract, I get 0, and I carry down the 1. Okay, 4 doesn't go into 1. So we put a 0 there, and the remainder is 1. So because the remainder is 1, I to the 41st power is going to equal I to the, whatever that remainder is, 1, which is I. Okay, so I to the 41st power is just I. Is this making sense? Let's do one more. Let's do I to the 23rd power. Okay, we'll do long division. How many times does 4 go into 23? And more importantly, what's the remainder? Okay, 4 doesn't go into 2, but it goes into 20. It goes in 5 times. Okay, 5 times 4 is 20. And we subtract here, and we have a remainder of 3. So I to the 23rd is equal to I to the 3rd. Okay, and I to the 3rd is -I. So you always want to take it down to one of these 4, either I, 1, -1, or -I. So we can't just say I to the 3rd. We need to take it one more step and say -I. Okay, that's it. I hope this is helpful.